Which table represents the equation y equals 3x? Before we do anything, what type of pattern is this?
Multiplicative.
Multiplicative because why?
Because there's a x by the number. Same
Yes,
like a
there's a
variable.
number next to a variable, right?
Yes.
If there's a number next to a variable, we are multiplying. Okay.
I feel like if those questions that we had like with $10, there was like this number beside a parentheses.
Which means to.
Multiply.
Yes. Okay. So looking at F, do I need to even try that one?
No.
Why?
It's
It's getting smaller, right? If I'm multiplying by a whole number, I'm going to be getting bigger.
Oh, Miss Ketchum,
Yes.
you can't do H either because it's saying the same.
I can't do H if I'm multiplying a number by
0.
If I'm multiplying 1 by 3, it's going to be 3.
3.
not 1.
If I'm multiplying a number by anything besides 1, it's going to be a bigger number, right?
Yes.
If I was multiplying by 1, would this be my answer?
No.
Yes, it would. Because 1 times 1 is 1, 3 times 1 is 3, 5 times 1 is
5.
7 times 1 is
7.
But my rule is 3x, not 1x. Okay, so now I've done no work, really, and I have a 50% chance of getting it correct. That's much better than 25%, right?
Yes.
Much better odds. So now I'm going to have to go through and multiply each x by 3 to see if it's right. 1 times 3 is
3.
That works. 3 times 3 is
9.
That works. 4 times 3 is
12.
That works. 7 times 3 is
21.
That works. That's a possibility. We're gonna check it. 1 times 3 is
3.
That works. 4 times 3 is
12.
That's not correct. Any one wrong makes the whole thing.
Roll.
So my answer is
G.
Yeah.
Miss
Ten.
Ketchum.
Yeah.
On the second one,
Hold on. You'll be respectful.
on the second one to get 9, wouldn't you have to multiply 2 times 4 and add 1 to get 9?
I don't know off the top of my head, to be honest. I don't really know. I didn't have to look at that to see what rule that follows.
Just had to look at it for 9.
Okay. Which table could represent the equation y equals 1/10x? Yes, Paige.
Oh, I guess which one we can take out.
Which one can we get rid of?
F and H, because how does 5 times 1/10 get you 50, and then it's not adding 1/10, it's multiplying.
Very good. So that's a key part of a really good point. This is really good number sense. Everyone, girls, listen. 1/10 is less than 1, right?
Yes.
So if you're multiplying a number less than 1, your answer is going to be
Smaller.
smaller. This is multiplying by what to get y? 10. Is that 10 or 1/10?
1/10.
So a $10 bill or a dime, are those the same value?
No.
No. So F is not correct. On H, he says, to get this, I'm adding. Do I have an additive pattern or multiplicative? So H is wrong. Same thing. We are down to a 50% chance of getting it correct.
Well, that's additive right there, yay. On the second one.
Yeah, because it's just adding 1/10. Because 10 times 1/10 is $1.
Well, let's go through it. Okay. So I can tell the majority of y'all probably don't know that off the top of your head. So let's practice going through it. So I'm gonna go here. 5 times 0.1. Remember, when you multiply decimals, you line it up against the line, right?
Yes.
1 times 5 is
5.
5. Is there a decimal here?
No.
Decimal here?
Yes.
Yes.
Plate numbers between the line and the decimal point.
1.
So I'm moving the decimal over. 1.
1.
Is 5/10 correct?
Yes.
Okay. All right, let's do 10. 10 times 1/10.
Equals
1 times 0 is
0.
between the line and the decimal point? 1. So there, I'm moving decimal over one place. No, I'm not moving it down. I'm moving it over. I see that a lot. I just want to move it down. Make sure you're moving it over the number of correct places. Is this correct?
Yes.
All right. 15.
Yes.
That's right.
You don't have to.
It
Wow,
could
we're
be.
going to do the work though.
It could also.
1 times 5 is. 1 times 1 is. Decimal here.
No.
Decimal here.
Yes.
Number of places between the line and the decimal point. Moving it over how many places?
1.
Guys, is this correct?
Yes.
We're not in an opera. Please stop.
Another pattern that it looks like it's doing is adding by 5. Like it's not additive, but
It's
on the
moving
right
the
it's
decimal
going.
over 1.
Yeah, it's like it keeps adding 5 to it on the right.
Okay, let's look. 20 times 1/10. Not 1, 1/10. 0 times 1.
0.
1 times 2.
2.
Decimal.
No.
Decimal.
Yes.
Places from the line of the decimal point is
1.
moving it over.
1.
Correct. And then 40.
Time.
1/10 equals
0 times 1 is
0.
1 times 4 is
4.
decimal.
No.
Decimal.
Yes.
From the line, the decimal point there is how many
One.
places?
One.
Okay, uh-oh. I'm moving it over how many places?
1.
Just don't roll.
Alright.
4.
So all those are correct. Do I need to check this?
No.
No, because
Yes, I do. What if I multiplied wrong here somewhere? I still have to go over and check my other choice. Okay, I already know that this should be 5/10. Is that correct?
Yes.
I already know this should give me 1. Is that correct?
No.
As soon as I get an X, it is
Wrong.
wrong.
Oh, it looks like that one on the right is additive.
Wait, you
but
gotta
one.
circle 0.6 where you know which.
Alright,
There we go.
there you go.
There.
Let me circle these for you too.
Okay.
Alright, we go on?
Yes.
Awesome. Last problem.
Oh, this is the one that tricked me.
Oh wait, what about the other ones? We still have one on the page.
I only have this last
This
one.
is the one right there.
It's the same one. She just didn't put it on the same page.
Hold on, what?
No, I got this on the practice
Wait,
problem.
you have it on the same page.
What right there?
Look,
What?
Oh, I see.
Hold on, keep going.
look.
I don't
No, go to the next
I
one.
don't have it.
Oh yeah, we skipped a couple of them.
We did?
Yeah,
Look.
we skipped like yeah, we skipped the whole entire thing.
Look.
Stop saying stupid things. It's after multiple.
Okay. We can do those tomorrow. Sorry.
Oh my god, there's something for nothing.
Okay.
No, I don't got
Those are from Thursday when I was out, right? I only did a couple of them.
I did.
Okay. So, customers at a gift shop receive free stickers for every t-shirt they buy. The graph shows the relationship between X, the number of t-shirts customers buy, and Y, the number of stickers customers receive. Which table also represents this relationship? So, we need to first figure out what my X and Y are for these points and then find the rule. Okay? So we're going to draw a chart. And plug in. What is my X for my first?
1,
Okay.
and then 2
What's
for your
then
Y
2?
value, and then you have 2 for your next one. You got 2 for your X value and 4 for your Y value,
Okay.
and then 3 for your X value. And 6 for your Y value, and then 4 for your X value, and 8 for your Y value, and then 5 for your X value, and then 10 for your Y value.
All right. So, am I going to get my answer just by looking at these points?
No.
No. I have to figure out my rule first, right?
Yes.
And then I can go down here.
Yeah.
Wait, you see where we put X and Y? We should put rule in the middle.
We can put rule here.
Okay.
Okay. So I'm going to check adding first. What am I adding to 1 to get to 2?
1.
What am I adding to 2 to get to 4?
2. So that's
3 to get to 6.
3 to get the 6 is 3.
4 to get to 8.
4.
5 get to 10.
5.
You can also subtract. 10 minus 5 is 5, so I'm adding 5. 8 minus 4 is
4.
so I'm adding 4 to get from here to here.
10.
See how I'm doing that? I'm doing the opposite. Okay, now, are these rules the same?
No.
So is it going to be an additive pattern?
No.
Okay, let's do multiplying. 2, I can say 2 divided by 1 is, 2 divided by 1 is,
2.
okay. So that means I'm going from here to here is times 2. 4 divided by 2 gives me
2.
So that means I'm multiplying by 2. Okay. 6 divided by 3 is
2.
So that means my rule is
2.
what 2?
Times 2.
Times 2. If I'm going from here to here is dividing, I'm doing the opposite to go here to here. Opposite of dividing is
You put 3.
sorry. Opposite of dividing is
Multiply.
yes. 8 divided by 4 is
2.
10 divided by 5 is 2. Okay, so my rule is going to be
Times 2.
alright, so y equals 2x is my rule.
I got my answer and everything comes to
I want y'all to look at something real fast. Does this say x and this say y?
No.
But if I look at my x here and my y here, what's my x?
Number of t-shirts bought.
So this is
X.
number of free stickers is my
Y.
So label that so you know what goes with what.
I was kind of confused on this one. Like
What?
the number, and I was, but then I did.
It's okay as long as you understand as we go through. Okay, 6 times
2.
Times 2.
2. Does that give me 6?
No.
So
Circle it.
wrong. Okay, I want times 2. 6 times 2 gives me
12.
That's right. 7 times 2 gives me
14.
That's right. 8 times 2 gives me
16.
That's right. Oh, that's this time 2. 9 times 2 gives me
18.
That's right. So that's a possibility. 6 times 2 gives me 3.
No, that's dividing.
Wrong. That's dividing.
They're all dividing.
Yep. 6 times 2 gives me 18.
No.
6 times 3 gives you
Wrong. Yep. So, your
How did you
answer.
get?
Oh, what's your question?
Are there 2 times 10 times 2 get 20, not 30?
Yes. Well, this whole thing is times 3. My rule is not times 3. So my answer is
G.
questions on how I got that. Yes, Peyton.
I don't have a question on how you got that, but where did they get the number of t-shirts bought? That's what I was confused on.
So that
Because each T-shirt they bought was how many stickers they got. So that if they wanted to know how much stickers they bought or how much shirts they bought, they would have to.
those are just hypothetical numbers.
Okay,
So if we extended this line up using this rule, which one of these would match that relationship? Does that make sense?
You can draw the.
If let's see, I can't do a.
You can.
If I extend it to 6, 12, it would keep following that rule. Up, 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 and up.
Okay. You can. It's multiplicative because it's going to go into the origin.
But click to the tip.
Okay, questions, comments, concerns.
It's okay to tell us. Wait, how much